One of the questions that we posed in the last unit when we were talking about the area of different shapes, we said, well, what happens to the area if you double the sides? What happens to the perimeter if you double the sides? And what we learned, and this is what we did on our project too, remember that if you doubled the sides, right, we wrote our sides ratio 1 to 2. If we double the sides, then our sides ratio is 1 to 2. Remember, our perimeter ratio was also 1 to 2, and our area ratio was 1 to 2 squared, or 1 to 4. Well, today we're going to find out what happens then when it's two-dimensional, or when it's three-dimensional, and when we want to look at what happens to volumes. So I've shortcutted this just a little bit from what we did in the notes by giving you the lateral area, the total area, and the volume of each of these shapes. And I went ahead and set up the ratios. So the ratios of our corresponding parts, by corresponding parts, I mean the sides or the diameters or the heights, the pieces that go together. So with our cubes, our corresponding sides have a ratio of 5 to 2. So if you take your lateral areas, 100 over 16, and you reduce that, you get 25 over 4. And then your total area is reduced to 25 over 4, which is interesting to note. And then our volumes is 125 over 8. If you look at your cylinders, your parts, we've got our heights and our heights, our radius and our radius. Our height would be 6 over 8, which would reduce to 3 over 4. Our areas are both in a reduced ratio to 9 to 16, and our volume is in a ratio of 27 to 64. So here's what I want you to see. Notice that when my sides are in a ratio of 5 to 2, let's look at how our sides can create our area ratio. So it's 5 to 2 squared, or 5 squared over 2 squared. And this one was also 5 squared over 2 squared. And then our volumes are 5 over 2 cubed. We look at the cylinders, they do the same thing. We had our sides ratio of 3 to 4. Our sides ratio squared gave us our area ratios. It doesn't matter whether it's lateral or surface. And then sides ratio cubed gave us our volume ratios, which is interesting because if you think about it, our sides were in meters, our area was both in meters squared, and our volume was in meters cubed. And so our units can give us a hint as to what we need to do with the unit of measurement. So then our rule is going to be that if our parts are in a ratio of A to B, our area will take that ratio and square it. So it will be in a ratio of A squared to B squared. And our volumes will be in a ratio of A cubed to B cubed. Now where this is useful would be when you need to convert. Say you have trying to think of, okay, so say I have, 27 feet cubed, and I want to measure that, but the gravel I'm trying to buy is sold in inches cubed, which is probably the other way around. Well, I need to convert those feet to inches. Well, I have feet and feet and feet, right? And so since I'm in a volume measurement, my sides ratio is 12, right? For every 1 foot is 12 inches. That means for every foot, I need to include 12 inches, 12 inches, and 12 inches. And so that would be then 12 cubed. So that would be, 1 foot cubed would be 1,728 inches cubed. And so then that would be my multiplier to multiply by the 27 to see how many inches cubed. So this is useful, particularly in volumetric measurements when we're dealing with sand or gravel or concrete or anything like that, when you need to convert between feet and yards, or yards and feet and inches. And so that's where this comes in handy. Okay, so let's look at some just setting up some practice with our ratios. And so if we start with the ratio of our corresponding parts, then the ratio of our areas, right, that would be A squared to B squared. So if this is my A over B, or remember it could also be written 1 to 3 like that, then A squared to B squared would be 1 squared is 1 and 3 squared is 9. So it'd be 1 to 3 squared. The ratio of our volumes would be A cubed to B cubed. So that would be 1 over 3 cubed, which is 1 cubed, which is 1 over 3 cubed, which is 27. So that's when I started with my sides. Everything is based off of sides. Notice everything is in terms of A and B, like it's plain old A and B with no variable or with no exponents. Okay, so let's look. Now we started with areas. Well, I can't go from area to volume. You just can't. You have to go from area back to sides, and then you can go from sides to volume. So we're going to have to go backwards. Well, a squared to b squared is what gave me, so now I need to go backwards and get a and b. Well, if 36 is a squared and 49 is b squared, then a has to be 6 and b has to be 7. Now I can go over here and get my cubed. So now it's 6 cubed and 7 cubed. 6 cubed is 216. 7 cubed is 343. Okay, so on this last one, you started with volume. Remember, that is a cubed and b cubed. So that's where you cube root. You've got to do the 64, the cube root of 64, and the cube root of 125. Well, when you do the cube root of 64, you get 4, and the cube root of 125 is 5. Then you can go over here and get your area ratio. So it would be 4 squared and 5 squared, which is 16 over 25. So my areas would be in a ratio of 16 to 25. My sides would be in a ratio of 4 to 5. So everything has to come back to sides. So let's look at what this might look like. We start with a cylinder that has a surface area of 24 inches squared. Here's a hint right here, squared. If you double the length of the dimensions, so I'm going to double all my sides. So my sides have a ratio of 1 to 2. I started with 1 square, right, just like we did in the project. 1 square was 2 inches, and so because I doubled my sides, okay? So I want to know now, we're going to skip perimeter because we don't need perimeter of three-dimensional figures. So then let's go to our area. Our area ratio would be that squared. So 1 squared and 2 squared, which is 1 to 4. So my area ratio will be 1 to 4. Since even though we don't need it, I'm going to go ahead and do our volume ratio for practice. That would be 1 cubed and 2 cubed. So my volume ratio, if I did need it, would be 1 to 8. That's my multiplier. Right? So if my sides are times 2, my area will be times 4, my volume will be times 8. Well, I'm starting with an area, 24 pi, so I want to know my new area, so I'm going to use my area multiplier times 4. And so my new area, it doesn't matter whether it's lateral or surface, and I don't even care what the shape is, but the new area of my, now in this case, cylinder, is 96 pi. Now you can also think of it like this. You started with 24 pi. We're going to multiply by our double. So there's my times 2, but it's area, so I got to square it. And that's the same thing. So if it's easier for you to think of it like that, then do that. So we've got a square pyramid. It has a volume of 24 if all the dimensions are half their original size. So my sides ratio will be 1 to 1/2. My area ratio, just to think through all of them, will be 1 squared to 1/2 squared, which will be 1 to 1/4. And my volume will be 1 cubed to 1/2 cubed, which would be 1 to 1/8. So I want to know what the new volume is going to be, so I'm going to use my volume multiplier. So my original was 24. I'm going to multiply by my multiplier, my scale factor, and I'm going to get 3. That my new one is going to be 3 cubic centimeters, cc's. So 2 prisms are proportional. The height of one prism is 2/3 the height of the other. So there's a couple ways you can look at this. One is to continue like we've been doing. Sides would be 1 to 2/3. My area, I'm going to shortcut this, would be 1 squared, which is 1 to 2/3 squared, which would be 4/9. And my volume would be 1 squared, which is 1 to 2/3, 1 cubed, which is 1 to 2/3 cubed, which would be 8/27. So if I start with my larger one, okay, then I'm going to get it's going to be smaller because it's going to be 2/3 as big. Then I'm going to multiply. It's an area, right, or it's meters squared, so I want to use my area multiplier. So times 4/9, and that's going to give me 36. Now, that may not make very much sense to you, but this might help. if my ratio of my areas is 4 over 9, 4 is the small one, 9 is the large one, then 81 is the large one, so I put 81 on the bottom, and I can set up my proportion. I still cross multiply, and I still get that x is 36. So if that helps you to understand how to set it up, then do it that way. Okay, so let's look at these problems. So we have a scale factor of 1 to 2. Remember, you can also look at it like this. So scale factor means that's what happens to my sides, all right? And then we determine what happens to our area or our volume. So if what happens to my sides is 1 to 2, then I want to know what's going to happen to my area. Now, just because it's already set up like this, you've got 64 over your new, your old over your new, I'm going to just keep it set up and do a proportion like we did in number 3. So my surface area, my area should be squared, so I'm going to use a 1/4 proportion. So if you look at it like this, then you can do 64 over x equals 1 over 4. So 64 times 4 would be 256. So you just set up a proportion. What's important is the ratio that you use. For your volume, it would be 1 over 2 cubed. So that would be equal to 1 over 8. So if it's 1 over 8, then when I solve that, 28 times 8 is 224. So all I'm doing is I'm taking this and I'm deciding what the area ratio would be and the volume ratio, and then I'm setting up my proportion to solve it. Okay, so now I have a scale factor of 2 to 1. If we want to look at it like this, you can do 2 over 1. So my area ratio will be my sides ratio squared. So 2 squared is 4, 1 squared is 1. So I have this nice little proportion that's already set up for me. Cross, multiply, and solve, and you get that the area then would be 2432 pi. You can do the same thing here, but you would use cube. 2 cubed is 8, 1 cubed is 1. Set up your proportion, and you can solve it. And you get 1,500 or 15,360 pi. Now, on the next one, notice that on the next one, you don't have a sides ratio. So I got to figure out what happens to the sides in order to figure out what happened to the area. Well, remember that it was a squared and b squared, right? A squared and b squared. So if 36 is a squared, then a would be 6. And if b squared is 324, then b would be 18. Well, that will reduce, right? That's 6 over 18. That will reduce to 1 over 3. So now I can go in and I can say, okay, well, 1 cubed is 1, and 3 cubed is 27. And I can see that my volume ratio would be 12 times 27. So my other volume, my larger volume, would be 324. And then in the last one, we're back to giving you a scale factor, right? It's 2 over 3. Square it to set up your proportion to solve here, and you'll get 48. That doesn't seem right. Let me check that. It should be bigger than that. One, I think I did it backwards when I did my key. 108 times 9 divided by 4 should, oh yeah, that doesn't make, because you know why it didn't make sense to me? Because the 4 is small and the 9 is big. So the 108 should be small. So that should have been 243. Okay, then you're going to set up your cubed. So it would be 2 cubed, which is 8, and 3 cubed, which is 27. There's my proportion. Solve it. 54 times 27 divided by 8, and you get 182.25. Okay, so here's the big thing right here. This is the most important part. You need to remember whatever happens to your sides, square it. That's what's going to happen to your areas. Cube it, and that's what's going to happen to your volumes.